Okay, so here we will discuss like what if the function was maximization and we need to do it using the big M method. Okay, so similar to the other one, here we have a greater than or equal to constraint. So here we will add an artificial variable. Okay, so processing it, we get 2x1 plus x2, and here we subtract s1, which is surplus, and add an artificial variable. Similarly, for the second one, we will get is x1 plus 3xt plus s2 is equal to 3, and x2 plus s3 is equal to 9. Now, what we have processed, we need to show it in the maximization function. So we g minus 3x1 minus x2 minus 0s1 minus 0s2 minus m1 is equal to 0. Here m will be negative. Here the m value will be negative because it is maximization. So the rule is to add the m value as big as but in negative. If it is minimization, we add the m value as big as but in positive. So here the m will be negative. Now converting it into the standard form, we get is basic z. Now here only s1 is surplus, so we will ignore the surplus variable and we will add a1, s2, and s3. Here it will be x1, x2, s1, a1, s2, s3, right hand side, and the ratio. Okay, now here we find out that it is minus 3 minus 1. S1 is 0, A1 is minus M, and we can minus 1, we can say that M is equal to minus 100. So here we will put minus 100. This will be 0, this will be 0, and right hand side will also be 0. The minus S is for surplus, and plus S is for the slack. Where there is deficiency, for example, we have less than or equal to, yes, for less than or equal to, we used to add the slack variable. And for greater than or equal to, we need to subtract the surplus variable. Okay. And now we need to do is to find the one row. Here the coefficients are 2, 1. S1 is minus 1. A1 is 1 over here. S2 is 0. S3 is 0. And right hand side is 2. For this one, S2, we have x1 as 1, x2 as 3, S1 0, A1 0, S2 is 1, which is 0, and this is 3. For this one, we have x1 as 0, x2 as 1, S3 as 1 and all other zeros, and the right hand side is 9. So this is the standard form. Now we need to eliminate this plus 100, because minus into minus it will get us plus 100. Okay, so we need to get rid of this. We need to do an a row operation that gets rid of this plus 100. So now let me write it again over here and then get rid of it, and then we will move towards the software package. Okay, the rest is all like simplex method. It's not very different. It's the same only. X1, 2, S1, A1, S2, S3, right hand side, and pressure. Now we have -3, -1, 0, 100, 0, 0, and 0. Here we have it 2, 1, -1, 1, 0, 0, 2, 1, 3, 0, 0, 1, 0, 3, 0, 1, 0, 0, 0, 1, and 9. So now we have to get rid of this 100. How will we get rid of this 100? We know that in the A1 row, the value beneath this is 1. So if we multiply A1 by 100 and then subtract it from the Z, we can get rid of this 100. So what we will do is, do you understand what I said? Because here we have 1. So if we multiply this row, if we multiply this row with 100, here we will get 100 value. And then subtracting this row from the 0, we get a new Z row with this element equal to 0. So we need to make this 100 a 0 first, and then move towards the next process. So we find the new Z row, which is equal to old Z row minus 100 into A1 row. This is the row operation that we need over here. Now old Z row is -3, -1, 0, 100, 0, and 0, minus 100 into A1 row is 2, 1, -1, 1, 0, 0, and 2. So what we get over here is -3, -1, 0, 100, 0, 0, minus 200, 100, minus 100, 100, 0, 0, and 200. Now doing this operation, we get -203. In the next one, we get -1 minus 100 is -101, and 0 plus 100 is 100, and 100 minus 100 is 0, 0 minus 0 is 0, 0 minus 0 is 0, and 0 minus 200 is -200. So the updated initial table for iteration 1 will be ZA1, S2, S3, X1, X2. Hello? Yes, you want to make some question? Okay. X1, X2, S1, A1, S2, S3, right hand side, and ratio. Now this z will become minus 203 minus 101, 100, 0, 0, 0, and minus 200. You see, we got A1 here is 0. Now the A1 ratio, A1 is 2, 1, minus 1, 1, 0, 0, and 2. S2 is 1, 3, 0, 0, 1, 0, and 3. S3 is 0, 1, 0, 0, 0, 1, and 9. Now, this is standardized table, and now we can proceed to the simplex method. Now, as it is the maximization function, what we need to find is the most highest negative. The most highest negative over here is x1, which is minus 203. So, so x1 is the entering variable. Now, for the leaving variable, we need to find the ratios. Here we get 2 divided by 2 equal to 1, 3 divided by 1 is equal to 3, and 9 divided by 0 is equal to infinity. So you must ignore zeros, negatives, and infinities. And the least positive is this one, minimum positive. So, so x1 is the leading variable. And in this way, we can do the rest of the process and find out the optimal solution. And the pivot element is 2. Now you understand it. Okay, I think we can now proceed to the software package. And I can show you like how to operate Tora and how to find the optimal solutions in over there. Okay, there is a okay. I will switch to my laptop, but on my laptop I don't have the microphone. So if you want to make a question or you have a query, you can send a message uh, in the chat. Okay. No, I can hear you, but you cannot hear me actually. I don't have a microphone. It is like since I will switch to my mobile phone in case I have to explain something. I have both connected. Then I guess cam will work uh, if you want me to Okay, I will open my cam and then I will do the problem. Okay, let me open. Okay, can you see my laptop screen? That is why I wanted to share the screen and okay, here we have, do you have a software in your, do you have software in your laptop or PC? Okay, you have to download it. So if it were, available in your PC, that would be good. But anyhow, I can, explain it from over here, and then, you can follow up. Okay. Okay. So in the main menu, we have like, we have like eight to nine options. Okay. The first one is linear equations. Uh, the second one is linear programming. The third one is transportation models. The fourth one is integer programming, and then followed by the network models, project planning, queuing analysis, and some zero sum games. Okay. So the thing that we need to pick over here is the linear programming, the option two. We click on it, and here the screen changes to this one. Okay. There are two modes of input in here. First, the, fir- the first one is like if you have an existing problem, like you have something in your notebook or the what we use Word document like what we use here as in Notepad. Okay. The second one is when you want to enter the problem. So what we use is we will use the enter new problem input mode. Okay. And we will go to the input. This is the input screen of it. Here, okay, so there are three things over here. The problem title, number of variables, and number of constraints. Okay, so what I will do is I will pick a random problem and I will define it over here and we will get the solution of it in like in seconds. Okay, should I should I share the screen so you will understand it better? I don't have to pick the phone and all that. Yes, yes. You can give me as many variables as you want. So can you narrate the problem or you can send me a snapshot of it? I will put it. Okay. Okay, I will wait. Please. This is the maximization problem or minimization? Okay, um let me name it like Yusuf problem one over here. I named it Yusuf problem one. Now, please tell me what are the number of variables over there. Okay, we have three variables. I just put three. Okay, I will. Okay, now what are the number of constraints over there? Okay, we have three constraints over here, and we will enter. Now, this is the screen that will appear. Now, the first variable, we can, name it randomly. Like, for example, for the x1, we want to name it like vegetable one. The the second one is, or for example, for example, the first one I name it as laptops. The second one is mobiles, and the third one is as tablets. Okay, now tell me please the objective function of it. Okay, okay, 904x3. Okay, now the first constraint, let me, put the first constraint. Oh, tell me the coefficient along with the variables. X1 less than or equal to 200. Okay, for the X1, we will put the coefficient only 1 over here. In the first constraint, we have x2 is equal to 0, x3 is equal to 0, and it is less than or equal to 200. 200. Now, going to the next constraint. What is the next constraint? Can you see it now? That is why I wanted, to share the screen so that you can see exactly what I'm writing. Okay, first of all, yes, yes, but let me complete the constraints and then I will share the screen. Yeah, the second constraint is x2 gre greater than or equal to how much? 300? 100. Okay. Now, please, okay, now I will uh, switch the screen. Okay, hello. Okay, I switched to my mobile phone. I can. Uh, Sorry. Yes, yes. I want to apply. Anyhow, you can just find the final solution of it, or you can use the iterations of it, like the M method, all slags starting to. Yes, I can record it. You know, and then I will send it to you in WhatsApp, and you can see it, and you can do it again in your PC. Yeah. So just like I did some of the problems in the first lecture, I will send it too. Okay, okay. I will send it. I will send it. I will, do some extra questions, yes, and then you can, you will, understand it. So, yeah, this the solution is coming that it has unbounded solution. It has no feasible solution. It is unbounded. Yeah, some of the constraints are consumed, and some of the constraints are not consumed. We we will come towards the unbounded solutions like in the next 2 or 3 lectures, inshallah. Tomorrow I can do another lecture, and we will do the two-phase method, and then I will